Hello students, welcome to my YouTube channel. I am Shlok Kulkarni, and in this video lecture I am going to solve questions from Radar Theory chapter in Keith Williams Radio Nav book. I have done first 20 questions in the previous video lectures. I have solved questions from Oxford, also Oxford Radio Nav, similar chapter, that is Basic Radar Principles. So do watch those video lectures too. Now let's start with question number 21 in this video lecture. We will solve the 10 questions, question 21 to question 30. Question 21. Ignoring pulse length and flyback, a radar facility designed to have a maximum range of 50 kilometers will have a frequency of how much? So range is 50 kilometer. 50 kilometer is nothing but 50 into 10 raised to 3 meter, right? Now range is equal to speed divided by 2 into frequency. Therefore, frequency will be speed of light or speed of radio wave divided by 2 into range. Substitute the values. Speed will be 3 into 10 raised to 8 meter per second. Range will be 50 into 10 raised to 3. Right? So 3 into 10 raised to 4 divided by 2 into 5. So again 3 into 10 raised to 3. 3 into 10 raised to 3 pulses per second. So frequency will be 3000 pulses per second. This is your answer. Next, question 22. Which combination of characteristics gives best screen picture, meaning radar resolution, better resolution, the best resolution in terms of radial resolution and azimuth resolution? So radial resolution is obtained by half pulse width. Azimuth resolution is obtained by full beam width. Okay, so to get best screen picture or best representation of the target on ATC radar screen, it should have, the radio beam should be a narrow beam width and a short pulse length. Narrow beam width and short pulse length. This will create a picture which is the best in terms of radial resolution and azimuth resolution. Question 23. The maximum range obtainable from an ATC long range surveillance radar is approximately how much? So of the options listed, long range surveillance radar means they are talking about area surveillance radar. So the maximum range is 200 to 300 nautical miles. Okay, as given in the Oxford textbook, 200-300 nautical miles. Question 24. On which of the following radar display is it possible to get an indication of the shape and to some extent the type of aircraft generating the return? So it is possible to get this type of information on airport surface movement radar. Okay, so aerodrome surface movement radar, option C. Aerodrome surveillance approach radar, SSR, secondary surveillance radar, airborne weather radar. This all three types of radar in comparison to aerodrome surface movement radar are long range radars. Comparison to airport surface movement. Now this airport surface movement radar is primarily made or designed to get a complete picture of the airport surroundings, airport and airport surroundings, to give to ATC controller all the relevant information about all aircraft and other vehicles moving on the runways, taxiways, whatever other maneuvering area of the airport. Okay. In low visibility conditions, this ATC radar controller can use this radar screen and spot or locate different aircraft at different places, different positions. This is particularly useful in case of airports which are very huge, which are large international airports, which handle lots of traffic. And in low poor visibility conditions, the ATC radar controller will not be able to have a 360-degree view, or even if he has a 360-degree view, the visibility conditions are restricted. So in such scenarios, he can use this airport surface movement radar, which is very accurate. Why very accurate? Because the pulse repetition frequency, okay, the PRF is very high. The antenna scan rate is also very fast, 60 RPM, 50-60 RPMs per minute, and this conditions are favorable for generation of shape and type of aircraft. So the ATC controller will get to see the position of aircraft on the airport on its radar screen. In addition to that, sometimes he can also get to know by looking at those radar representations of the target, the type of aircraft, the shape of aircraft. Okay, so remember this. Sometimes, not always, sometimes. Which of the following equipment uses primary radar principles? Airborne weather radar. Primary radar is nothing but the transmitter is going to send a wave, a radio wave at a particular frequency towards the target, towards aircraft. That target, radio frequency or that radio wave will strike the target and get reflected back at the transmitter. This reflection will also come at the same frequency f, whatever that frequency. So the transmission frequency is equal to the reception frequency. Secondary surveillance radar is different. You're going to send, the transmitter will send the radio wave at a particular frequency. That radio wave will go to the target transponder, get reflected back at the transmitter at a different frequency. So let's say there is a ground transmitter, and in the air there is a transponder, airborne transponder. So this ground transmitter will transmit frequency at 1030 megahertz. The airborne transponder will receive this transmission, this interrogation radio pulse, and it will respond to this interrogation by sending another frequency wave, which will be 1090 megahertz. So as you see, as I said, the transmitted frequency is different from the reception frequency. This is the operation of secondary surveillance radar, or the secondary radar principle of operation. So secondary surveillance radar and DME both work on that principle of SSR, secondary surveillance, secondary radar. So option C is airborne weather radar is what works on primary radar principle. You are going to transmit a beam, a radio beam in one direction. Okay, that will strike all large raindrops, water droplets in the cloud and get reflected back at the transmitter. So the frequency is going to remain the same. Question 26. What information may be shown on ATC radar screen connected only to a primary radar system? So with the help of a primary radar system, you get two pieces of information. The position of aircraft, meaning the range of aircraft and the bearing of aircraft, whether it is at right hand side of the transmitter, left of transmitter, like that. So option A is aircraft position only. Bravo, aircraft position and SSR code, meaning transponder code, aircraft position, transponder code and altitude, aircraft altitude. So the correct option is aircraft position. Aircraft position meaning aircraft ka range and bearing. Now aircraft position and SSR code is given by secondary surveillance radar. Okay, transponder code. This is also given by secondary radar. Altitude is reported by a transponder which has a mode C capability. Same. This option A is the correct. In a primary pulse radar, you have a directional aerial for transmission, an omnidirectional aerial for reception, a directional aerial for transmission, and another directional aerial for reception, a directional aerial for both transmission and reception, an omnidirectional aerial for transmission, and a directional aerial for reception. So remember option Charlie. Okay, since you are transmitting the radio wave at a particular frequency and going to receive that radio wave reflection at the same frequency, you can use the same aerial for transmission as well as reception. So remember option Charlie is the correct option. One directional aerial for both transmission and reception. Question 28. Radio altimeter employing a continuous wave signal would have what? It will have a directional aerial for transmission, an omnidirectional aerial for reception, a directional aerial for transmission and reception, an omnidirectional aerial for transmission, and a directional one for reception, a directional aerial for transmission, and another one for reception, a directional aerial for transmission, and another directional aerial for reception. Okay, a directional aerial for transmission and another separate directional aerial for reception. Next, question 29. Ignoring pulse length, maximum pulse repetition frequency that can be used by a primary radar to detect targets at a range of 200 miles is what? So range is 200 nautical miles, which is equal to 1.85 kilometer into 10 raised to 3 meter. So range formula is speed divided by 2 into frequency. So frequency will be 3 into 10 raised to 8 divided by 2 into 200 into 1.85 into 10 raised to 3. Frequency will be 10 raised to 3 into 3 divided by 2 into 1.85. So 4 into 1.85 is 7.4. 3 divided by 7.4 is 0, 0.405 into 10 raised to 3 pulses per second. 10 raised to 3 pulses per second, meaning frequency is 405 pulses per second. Remember. Next. Again, we have to find pulse repetition frequency at a range of 50 nautical miles. So 50 nautical miles is equal to 50 into 1.85 kilometer into 10 raised to 3 meter. So range will be speed divided by 2 into f. So f will be speed divided by 2 into range. So 3 into 10 raised to 8 meter per second divided by 2 into 50 into 1.85 into 10 raised to 3. So 3, 4. So 3 into 10 raised to 4 divided by 2 into 5 into 1.85. So 3 divided by 1.85 is 1.62. 1 into 10 raised to 3, that is 1621 pulses per second. This is the answer. So we stop here. I will do the next 10 questions in the next video lecture. I hope you have understood all the 10 questions that I have solved in this video lecture. If you have any doubts, questions, let me know in the comment box. I request you all to subscribe to this channel and share this video with your friends. Thank you for your time. I'll see you in my next lecture. Don't